Good morning everyone. So in the last class we discussed about Newton's first law of motion, and now we will discuss the Newton's second law of motion. So as we know that this law of motion states that the rate of change of momentum is directly proportional to the impressed force and takes place in the same direction in which the force acts. This law enables us to measure a force and establishes the fundamental equation of dynamics. Now, consider a body moving in a straight line. So let the velocity be changed while moving. Let the m be the mass of a body, and this is the initial velocity of the body, and v be the final velocity of the body. A is the constant acceleration, t equal to time in second, which required to change the velocity from u to v. So here u is the initial velocity of the body, and F is the force required to change the velocity from u to v in t second. Hence, we know that the momentum is the product of mass and velocity. So for initial state of the body, the initial momentum is equal to m into u, and for the final state of the body, the final momentum of the body is equal to m into v, where m be the mass of the body, u be the initial velocity, and v be the final velocity. Now, the rate of change of the momentum can be calculated as mv minus mu divided by t. So by taking common m value, we have v minus u divided by t. Hence we know that v minus u by t, that is the rate of change of velocity. That means rate of change of velocity is equal to acceleration. So we can put in place of v minus u divided by t as m into a. So according to the Newton's second law of motion, the rate of change of momentum is directly proportional to impressed force. That means F is directly proportional to ma, because ma is the rate of change of momentum. Hence, by giving the equal symbol here, we can write F equal to kma, where k is the constant of proportionality. That means k is a constant. For the sake of convenience, the unit of force adopted is such that it produces unit acceleration to a unit mass. Hence, F equal to ma, that is mass into acceleration. Now, this second law of Newton's law, it is also known as law of dynamics, and it consists of following two parts. So in first part, a body can possess acceleration only when some force is applied on it, or in other words we can say, if no force is applied on the body, then there will be no acceleration, and the body will continue to move with the existing uniform velocity. Then in the second part, the force applied on body is proportional to the product of the mass of the body and the acceleration produced in it. It will be interesting to know that first part of the above law appears to be an extension of the first law of motion. However, the second part of the independent of the first law of motion. Now, the absolute and gravitational units of force. So as we know that force equal to mass into acceleration, which we derived from the second law of Newton's law. Now, if the force is in Newton, then mass is in kg, that is the absolute unit. And if the force is in kg, then the mass will be in slugs. And if the value of acceleration is in meter per second square in both the cases. Now we have to find out the force value. So here is the numerical. So in this case, we have to determine the force which can move a body of mass 100 kg with an acceleration of 3.5 meter per second square. So now the data given are mass of the body, that is m, is given as 100 kg. The acceleration of the body is 3.5 meter per second square. Hence, the force is equal to ma as per the Newton's second law. So that we can find out the force by multiplying mass into acceleration. So mass is 100 and acceleration is 3.5. Hence, the value of force is equal to 350 Newton. The next question is, a body has 50 kg mass on the earth. Now, we have to find out its weight, beat 1 on the earth and beat B on the moon. So, in case of earth, the value of gravitational force is equal to 9.8 meter per second square, and in case of moon, the gravitational force is equal to 1.7 meter per second square, and beat C is on the sun, where the value of G is 270 meter per second square. So first of all, we have to write all the data given here. So mass of the body is 50 kg. Acceleration due to gravity on earth is given as 9.8 meter per second square. Acceleration due to gravity on moon is given as 1.7 meter per second square. The acceleration due to gravity on sun is given as 270 meter per second square. So first of all, we have to find out the weight of the body in each and every place. So first of all, beat 1, the weight of the body on the earth. So as we know that force is equal to mass into acceleration. So here the acceleration is given as acceleration due to gravity. So we can replace the A by G. Hence F1 equal to m into GE. So mass of the body is given as 50 and acceleration due to gravity for earth is given as 9.8. Hence the weight of the body is equal to 490 Newton. Then for the second beat, we have to find out the weight of the body on the moon. So for this case, we have to multiply the mass of the body with the acceleration due to gravity on moon, which is equal to mass of the body is 50 and acceleration due to gravity on moon is equal to 1.7. Hence, the value of weight of the body on the moon is equal to 85 Newton. Now coming to the last part, that is the sun. So now the weight of the body on the sun we can find out by multiplying the mass of the body with the acceleration due to the gravity of sun. Now the mass of the body is 50 and acceleration due to gravity on sun is equal to 270. So by multiplying this, we have 13500 Newton. Hence, the weight on earth is 490 Newton, the weight on moon is 85 Newton and the weight on sun is 3500 Newton. By converting this Newton into kilonewton, we have the value of weight of the body on Sun as 13.5 kilonewton. So this is all about chapter 6. So today this much. Thank you.